as you know, that you have to maintain decorum all the time. If you have any doubt, text me. Otherwise, what you can do is wait till the end of the discussion of the question, and then I will allow you guys to turn on your mics, and then you may ask the doubt. So I hope my screen is visible. If it is visible, please raise your hands. Okay, perfect. So today's topic is again STL, but we are talking about specifically we're talking about maps and sets, right? So let me just get my pointer. Maps, sets. So firstly, what is a map? Now before map, let's talk about what is hashing. So I actually did not have enough time to write about hashing here, so I'll just give a quick brief on Geeks for Geeks. Hashing is actually a technique that you use that efficiently stores and retrieves data in a way that allows quick access. So how does that work? You see, you have some data here in a list. You have 11, 12, 13, 14, 15. You perform some operation on this data, and then it gives you an index. So 11 modulo 10 gives you 1. So that means you store this 11 at 1. And 12 modulo 10 gives you 2. You store it at 2. Similarly, you store all these numbers at 10. Now, there could be chances where you get something like 21. So 21 modulo 10 is actually again 1. So 11 and 21 would collide here. So those are known as collisions in hashing. This is a very brief or scaled down version of hashing. There are a lot more examples of hashing, a lot more different techniques used in hashing. For example, double probing, single probing. But that is something you would not need right now because we are using built-in functions for hashing. So let's start with what is a map. Now, somebody very wise once said, "Don't be Dora the Explorer. Learn how to use maps." Some CCS guy. So map in C++ is actually nothing but the mapping of key value pairs that use hashing for fast lookup. So what happens here is you have some key and you have some value. Now, whenever you have some key, it points to a value. Similar, you can see two keys point to some values. Now, this do not worry about that. This is unordered map or are hash maps like dictionaries in Python? Exactly. They are like dictionaries in Python. So the thing that happens here is that these are pointing to some values. Now, do not worry if it is an unordered map or an ordered map. We will be talking about that later. But let's just tell you what it is. Keys are always unique in a map. So when you have a map, you have some key. So it will always be unique. That means two keys cannot exist in the same map that are same. So that would have collisions, right? So you have two keys pointing to two different values. That would be wrong. That would not be consistent. If anybody of you has any idea about databases or SQL, you see that there is a unique constraint in that. So similarly, keys have to be unique. That means if you associate something with some key, the next time you associate something with that same key, the association or value gets overwritten. Hence, only one copy of that key persists in the map. So that means if I say that this key is pointing to this value, and later on I say that this key is pointing to this value, then that would mean that this new value has overridden this value. And here you see two different keys pointing to different things. Now, what about values? So you find stuff based on what the value of the key is. So you have some key, it has some value associated with it. Hence, keys need to be unique. But that does not mean your values also need to be unique. Your value could be anything. As long as your keys are unique, your keys are pointing to something. Now, hence this constraint does not apply to values. You could map different keys to the same value. However, just give me a minute. I'm sorry. So here's the thing. You could map different keys to the same value. However, you must not think that if there are two same values in the map, it's just a singular value that is being referenced. That is not the case. So the thing is, you have one mapping to 3, 2 mapping to 5, 3 again is mapping to 5, and 4 is mapping to 6. Now you might assume that what happens there is that 2 and 3, since both of them are mapping to 5, there's a singular 5 in the key part, and it is being referenced by both of them. That is not the case. The thing is, each key has a different, has a unique memory location where it stores its value. So this 2 has 5 at some location, let's say 0x1, and then this 3 is pointing to this 5 at 0x2. Even though these 5s are same, but that does not mean both of them are referencing this 5, that singular 5. It's actually both of these have different locations in memory. So as I said, this is the right way to think of this, and this is the wrong way. Because assuming, let's say you delete this 2's record, that would also mean that 5 gets deleted, and hence 3 would be left with no value. That is not the case. In case you do decide to delete this 2, it's actually this 2 gets deleted with this 5. And then this 3 and this 5 still persist in the map. Now that's a lot of theory. We will be again studying the maps. I'll open my text editor and tell you everything, code editor to be precise. So why use maps? The thing is, maps are useful when you're trying to solve something that is related to counting, something that is related to grouping, frequency, frequency tracking, or fast lookups. Fast lookups are when you want to find the memory, find the value of something, but you do not want to spend a lot of time finding it. For example, if you have an array and you know that your value is present at index 3, so you can just say array of 3, and it's a very fast lookup. It gives you the value instantaneously in what we call as O of one time or constant time. Again, here's something for you to remember, that hash maps are very strong in the community. Whenever you ask somebody, hash map can be used almost everywhere. It's very useful. Now let's talk about what is the difference between a map and an unordered map. We do know that both of these have mappings between keys and values, but what is the difference between a map and an unordered map? So you see, again, I was very lazy to write my own self, so I did tell you what it means. So feature, let's talk about header file. You know what header files are. For example, in C, you used to import stuff. So a map has to be imported by, again, hash include map, and then you have unordered map for this. So do we care? No, because we will be importing almost everything, so not as of now. So underlying data structure, red, black trees, hash table, you do not need to know about this as of now. Ordering of keys, this is very important. As I mentioned, this is a lot. This is of a lot of importance. But the reason being that when you have a map, it is always sorted by default, and it is of course sorted in ascending order. And when you have an unordered map, it is not sorted. The reason is that you have hashing, and hashing cannot be sorted in an easy order because you do not know what the keys you're using, and you do not know what hash function you're using. So the order is random. Later on, we will be looking at this example. So the order in an unordered map is random. As the name suggests, it is unordered. You do not know the order in which stuff is present. So when you try to iterate in the map, you do not know which value you will get first. However, in map, you know whatever you're storing, sorted by key or value. It is sorted by key. You cannot sort on the basis of value. The thing is, you have keys pointing to values. So it is almost natural that these things are unique. So it is natural for you to sort based on these and not these. Because you can access a value by a key, but you cannot access a key using a value. You cannot say map of this value will give you this key. No, you do not know that. What you do know is that this key is pointing to this. So you can say map of this key will give you this. Now, let's talk about time complexity. So these are, as you know, sorting sorting is when you put the stuff in order. So this is O of log n, and insert delete search delete. The reason being that when you have something in a sorted fashion, I hope a lot of you know about binary search. It takes log n time complexity. So, but here in unordered map, it is O of 1, average, and O of n worst case. I'll tell you the reason behind this. So the reason it is O of 1 is that when you have very good hashing, when you have a very good hash function, and you can easily resolve where your value is. But the problem arises when you have a hash function that is not very optimized to your case. So it gives an O of n worst case. So it's a trade-off. Average O of 1 is very good. So that's why we prefer unordered map wherever we can. And O of n worst case rarely happens because C++ has a very good built-in hashing functions. So now key uniqueness. Of course, we do care about this. Keys must be unique. Keys must be unique. So inshallah, that is something that always happens in a map. Doesn't matter if it's ordered or unordered. It is always unique. Keys are always unique. Traversal order, as I said, these are in sorted order. Maps, these are not in sorted order. These have no guaranteed order. So this could be sorted, but we do not know. So performance on average, this is slower because it takes logarithmic time. This is usually faster because it takes constant time. It could take off n time, but that's very rare. And memory usage, again, no hash table here because hash table is used to find the values. However, here you do have a hash table, so that needs a little bit more memory. Custom key types, we don't really need it, but you overload this. And in unordered map, however, it requires custom hash functions, which we will use once we go very deep into the questions, very hard questions. But as of right now, we do not need them. Let's talk about use case. So map, we know stuff is ordered, so we use it when order matters. When you want to know that whatever you have stored is in a relative order, it is in ascending order. When we talk about unordered map, however, when fast access matters, you do not want your stuff to be in order, or you do not want that it gives in a particular way, but rather you just want fast access. You want the stuff to be in hand as fast as you can. So let's talk about an example here. So we look at this. So this is the order of mapping. Remember, this is how we'll map. So first we put a key of 4 associated with a value of 10. So let's talk about unordered map. So our map, when we put a key of 4 associated with 10, we see that 4 is pointing to 10. And in a map as well, this is also true. 4 is pointing to 10. But when we put the second value, that is 3, 4, we we do not know how is it ordered inside the unordered map. It could be 3, 4, or it could be 4, 3. We do not know because it is unordered and its order is guaranteed by hash function. So we also do not know about hash function. So this could be any order. But when you this arrow is wrong by the way. So but when you look at this map, we said that stuff inside this is always ordered. So initially you had 4 and 10. So when you put 3 and 4, you see 3 is smaller than 4 in ascending order. So 3, this 3 is supposed to be mapped with this 4 by the way. So this is a little wrong. This 3 will be mapped with this 4, and this 4 will be mapped with this 10. And when you put 6, 7 further, again, unordered map, we do not know what will be the ordering inside this. Because unordered map, as long as there was one element, we know it would be present in the same way. But once you put 2 elements, it could have been 3, 4, or it could have been 4, 3. In this case, it could have been 4, 3, 6, 3, 6, 4, and a total of 3 factorial permutations are possible. So any of the 6 ways it could be present. But in this case, we do know that it is always sorted. So that's the reason. First we have 3, then we have 4, and then we have 6. So 3 is pointing to 4, 4 is pointing to 10, and again 6 is pointing to 7. Similarly, when you put a 12, 9 inside, this becomes 3, 4, 4, 10, 6, 7, 12, 9, because this is ordered in ascending order. But the problem is, again, unordered map, we do not know what order it is present. And once you put 0, 3, any guesses where would it go inside? Anybody any guesses? Where would this 0 come? Here, 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 where? Drum roll, please. And 0 goes at the top. The reason being that map is always ordered. So it's 0, 3, 3, 4, 4, 10, 6, 7, and 12, 9. You see, this initially had this very vague order, but once you put it inside a map, it becomes like this. But once we talk about unordered map again, we do not know how it would be. It could be in any of the 5 factorial ways. Let's talk about this. Now, each arrow represents the state of both maps after the insertion of this key value pair. So I have, in case you want to read this again, this means that this is the state after insertion of this. This means insertion of this, and this means after insertion of this. And unordered maps use hashing, and if we're not certain what sort of hashing function it uses, and answer what values it has in hash table, we cannot accurately know in which order it is present. So unless you know what hash function it is using, how is it colliding, how is it handling the collisions, we do not know what order it is present. Maps, however, maintain a sorted order of keys. So here is a sorted order of keys, and use a tree structure like red-black trees. You do not need to worry about what red-black tree is, but just need to remember that maps use a sorted order. Hence, it is present in this way. Now, how do you create maps? So you first of all write unordered map. When you write, you have this angular brace starting. When you write the first data type, the data type you want to have of the key. Then you write second data type, the data type you want to have of the value, and then you write the name of the map. So here, same goes for map. You write data type 1, data type 2, map name. So this is of key, this is of key, this is of value, this is of value, and this is again the name of the map. For example, you could have a frequency of each alphabet as a map, and where you want to map character to an int. That means you want to know the frequency of every character to an integer. So there could also be an unordered map where you want to write string int, that means total marks. You can have names of people and then also have the marks right there. So how do you push values into a map? Let's see, here we have created our very own string, CSS coding community, and then we have a map. Remember, it's a map, so it will be sorted. So we write character int frequency of each alphabet. You have this map here, the frequency of each alphabet. So once you iterate over the entire string, I0, I less than name dot size, its name. So you say frequency of each alphabet. Now this is the name of a map, and then you put square brackets. Inside you write name of I plus plus. What this does is you have name of I as a particular character. For example, we begin with C. So it's going to do frequency of each alphabet and then inside C plus plus. So initially the frequency of C inside the map was 0. I've also explained why was it initially set to 0 and not any other value. So it increases by 1. So it becomes 1. After it becomes 2. And you can see there is no other capital C over here. Always remember that capital C and small c are different characters because each of them hold a different ASCII value. So that's why once you print the frequency of each alphabet, capital C, you get 2. Then small c, you get 2 as well because of this C present over here and this C. And when you try to put frequency of space, now see this is space, you get 2. The reason being you have a space here and a space here. When you try for a capital T, you get 0. Even though there was no capital T present here, the reason you get 0 is because by default, when you try to map a character of anything to an integer data type, you're trying to map something to an integer data type, it will always have a default value of 0. In this particular example, so the default value of any new key will be 0. Yes, as long as your value type is integer, it is integer or it is long, let's say. But I also have some homework for you guys. So you have to check if similar behavior exists when we set value as character, string, boolean, etc. So let's say we have a boolean. We are trying to map this character to a boolean. So you know boolean can have true or false. So there could be a possible case that boolean has all the default values as false or true. That is your homework to check. You have to check. You have to create a map and you have to check is that the case. Apart from that, in this particular example, we map a character to an integer type. Now, by default in maps, both maps by the way, integer types have default values of 0. Integer types, when I say integer types have default values of 0, I mean when integer types are present in the value, not in the key, when they are present in the value. Now that is why when we searched for frequency of t, we found that it was 0. Even though we know that there is no t present here, but when we try to access the frequency of t, it gives back 0. That doesn't mean that it has mapped t to 0 in itself. It's just since t did not exist as a key, it returned the default value 0. I hope you guys understand this. I will also have some more examples for you. I'll open my code editor as well and show you. So before that, let's just see how do you iterate through maps. So we've seen how to create a map. Again, this is how you create a map. You write the name of the type of the map you have, and then two data types, and then again the name of the map. As we saw, map character int name of a map. And how do you iterate through a map? Now, if anybody of you attended yesterday's class, I taught you about iterators. Let me just see if that exists here. Yeah, I remember teaching about iterators there. So here we go. So to iterate through maps, use iterators. Now, iterators, as I told you yesterday, we did deal with two iterators, begin and end. So I taught you that begin is where quick revision. Begin is where your stuff starts. So in this case, this is where your vector was. Your v.begin was where it started, and your end was where it ended after that. So it ended at 0, but your end is after that. So anything after this 0, let's say we have one more element 1. So end would be after this 1. So begin starts where your vector, or in this case where your map starts, but end is where your thing ends after that. So similarly, we use this to iterate through map as well. Both maps, by the way, it doesn't matter if you have unordered or ordered. So a special keyword is used, and it is known as auto. So what auto does in C++ is it assigns the data type of whatever you're trying to a variable. Let me just give you one more thing. First of all, as you saw, CC's coding community, we put the name, we put the frequency, and what we're doing here is once we put the frequency of each character into, once we put the frequency of each character into the map, in this case it's a map, remember, not unordered map, so it will be sorted. You saw is we wrote auto iterator. Again, this it means that it's an iterator because of the auto keyword. Auto iterator is equals to frequency of each alphabet begin. How this thing works is, first of all, it sees okay, so this is frequency of each alphabet. This is my map, and when you put a dot begin in front in after that, what it gives you is an iterator. This dot begin, this entire thing will give an iterator that begins at the starting of this map. Now, since this is a map, it will be sorted. So you see, this is the order you will get the answer. So the smallest thing you get here is space. Now I believe the ASCII code of space is actually smaller. Let me just look at it. ASCII code of space. So it is blank space is 32. The ASCII code of space is 32, and you know the ASCII code of 65 is for A. So 32 comes before that. Remember, it is always sorted based on ASCII code, and otherwise it could also be lexicographical order after you're done with ASCII code. So here we saw that space has a frequency of 2. How do you access that frequency is based on this. First of all, your auto iterator is equal to frequency of each alphabet dot begin. This will return you an iterator that begins at this place. It begins at the start. So it began at the start, and you also write a condition that iterator does not equal to frequency of each alphabet dot end. The reason we do this is because when this thing will run, when iterator will be equal to frequency of each alphabet dot end, means you have reached the end of a map. It will go through this, it will go through this, all the way till the end. It will not go through here. I mean, it will go through here, but it will not mark this as end. It knows that end is once you've exited the map. Once you're done with the entire map, the end is always present after the last element. This is the reason the end is present at the last element and not here. Because you need to know when the map is over. As you know that there is a null termination thing in strings, as you might have studied in C. End is also a similar concept. End marks the end, the actual end, not this, the last character. Once you're done with the entire thing. That is why we write does not equals to. It only becomes equals to this thing, this end, once you have exited the map. Or let's say once you try to access something that is not in the map. So let's say you try to access the frequency, or you just try to just dot and point at the last element or at the byte just beyond the last element. Sure, yeah, it points at the last byte. I also remember your doubt from yesterday. See this right here, this is not intended behavior. This should by all means give you a garbage value because endpoints, where did I write? Endpoints here. So this should give you a garbage value. This for some reason gave me 0 on my compiler, and when I tried it somewhere else, it did give me a garbage value. But this over here, minus minus v dot end, it gives you 0. This is the intended behavior. See, this is end, so this is v dot end. So minus minus of that would be this 0. So it gave you this, right? This is not intended. That's why I've specifically marked this, and I've tried to explain that I do not know why this happened. I hope it cleared it out. So apart from that, let's see. So here what happens is, you try, it is does not equal to frequency of each alphabet dot end. What is auto do? So yeah, again. So auto actually automatically gives or assigns the data type required. So let's first try to understand what it is here, then you'll understand. So you see it dot first, or it, however you access this, first gives you the key. All these are keys, and all these are values. Since all of these are values, it's at second, it's at first. So by all means, if your it is firstly giving you a key and later it's giving you a value, what should ideally be its data type? You do not know. You could say it could be a character, comma, int type, or you could say it's a hybrid type, but rather it assigns the data type based on whatever this thing is. Auto, for example, if you were to say auto iterator is equal to 5, now auto will assign the required data type to it based on what 5 is. Now 5, as you say, is an integer value, so it will somewhere behind the compiler it will assign it some value, some data type that is similar to an int, so that you can hold all such values. So, for example, if your map was not character int, it was, let's say, string and then int. So it will assign that string comma int data type to this int. That is the role of auto here. A special keyword auto is used to define the data type of that iterator. So let's see again. So what you do is you firstly say that start auto at begin. Now begin is again the iterator. This entire thing is an iterator. And then you say that do this until you reach the end. Now end is not this, as I said. End is this thing, the byte just after this. Once you've entered the map, this is the end, and you can easily iterate through this using iterator plus plus. That works with this case as well. So you see iterator dot iterate first and then iterator second. You see we have space C, S, C, D, G, and all this is in sorted order. Of course, this C has a lower ASCII value than this small c, and that's why also these are treated differently. And you see this space also. This is actually there's a Y missing here. This is actually space, also known as space. So this is what happens when you use a map. But what would happen if you were to use an unordered map? You see the order here is random. The space is here. The capital C is here. The small c is here. The G is here. The D is here. The O is here. O is before D, even though alphabetically or lexicographically, as you say, D should be present before this O. And by all means, this space should be at the top. But since we've used unordered map, there is no fixed order. The order is random. It's not random every time. If you were to run this code again, you will still get this thing because the hash function is same. The hash function will change once you put in a different value. So, or it will give you a different answer. That's what I mean. So, I guess you know the difference between map and unordered map right now. Now, there's one big pro tip here. So, arrays versus maps for questions. So, you could have questions where you want to count the frequency of some elements. So, you might say, okay, why don't I just use an array? Why use maps? Because it's very hard for maps to not use maps. The reason you do not use an array is, let's say you have an example where you want to count the frequency of some elements. Let me just grab it. So you have 1, 2, 3, 1, 1. So once you can possibly create an array and you say that this is pointing to 1, 2, 3. So the frequency of 1, 3, the frequency of 2, 1, the frequency of 3, 1. Perfect. But let's say you had 1, 2, 3, 1 million, and 5. You can't say that you're going to create a new array of size 1 million. So what you're trying to say is if 1 is 1, 2 is 1, 3 is 1, 5 is 1. And then somewhere after a lot of values, there's 1 million. And entire thing is not of use to us. This entire thing from 6 to 99999 is of no use for us. What we're trying to say is that this is not continuous. This was continuous. This was easy. It was easy to implement. But once you get very large value, you do not know how far that value is. So it's not like you first find the largest value and then you're creating an array of that size. Because all this space is not of any use to us. Because all this will be filled with zeros. So once you do not have continuous data, you use map. But once you have continuous data, you know you will only have value from 0 to n minus 1, or let's say 1 to n. So it is very easy to just use an array. But once you know that you're going to have values, you do not know how big, or they are going to be discrete. And you should always prefer using map. Again, this example. So an ordered map is an array where the keys are the indices. Uh, Ordered map is an array where the keys are the indices. Yes, see the keys are always going to be the indices, regardless of if it is an ordered map or an unordered map. It's just in an unordered map. Oh, I'm still using a pen. Sorry. It's just in an unordered map, the order is not fixed. Also, you just say map. You don't say ordered map. I don't know why they did like this, but it's just map, and here it's just unordered map. So here's the thing. You use arrays when you know how many distinct elements are present and they are continuous in nature. Example, you can use arrays for counting the frequency of lowercase letters. Let's say this entire thing was in lowercase, and you just wanted to know how many letters are present. So you know it's 26, and you know that alphabets are always like A, B, C, all the way to Z, and it's like 0 to 25 indices. So that's easy. It's not like Z is present at 1 millionth index and then A is present at 0th index. So it's continuous, it's easy, you can simply use an array. Or you can use to count the frequency of continuous numbers 1 or 0 to n. You use maps when you do not know if data is continuous. For example, I told you if we have 1 to 1 million and 3, you can't say that you're going to create an array of size 1 million and then you're going to put all the elements inside that. And you're going to say 1 is present one time, 2 is present one time, and every number from 4 to 9 is present 0 times. So that will use of n memory. The map will use of in memory, but once you have an array for such operations, it will use of max element memory. Your max element here was 1 million. Even though you only had 4 distinct elements, if you were going to if you were going to map it like this 1, 2, 3, 4, all the way to 1 million, and say that this index refers to its frequency, so 1 is 1, 2 is 1, 3 is 1. So that is going to take max element type memory. But once you know the data is continuous, it's like 1, 2, all the way to 26, then it's easy. Just use an array for that. Now there is of course sets. We'll begin sets shortly, but before that, I would like all of you to tell me if you have any doubts. You can put your doubts inside here in the chat. Also, I will be showing my code editor soon, so let me just open the code editor. See, I have allowed all of you to turn on your microphones. So if anyone of you has any doubt, just turn on your microphone. Let me know. By declaring map first data type is always okay. Yes, always. Always key then value. We will practice some examples. You can turn on your mic, it's completely fine. I hope my screen is visible.
हाँ भाई
Is
यार
visible, please. Okay, good. So let's move this another thing. Do not worry about what this is or what this init code is doing. We'll see that. But right now, just worry about it. So let's create a map, right? So we're going to create an unordered map of character to we're going to count the frequency of each letter in my name. Okay. Can I use a map as the key of another map? It's actually in a map. It's actually very hard. There are restrictions. Sometimes you cannot use a vector as a key because it's very hard to compare. I think in an unordered map you cannot use, but in an ordered map you can use. But you will not have the cases where you will have to use like a map is pointing to another map. You use different things for it. So let's say we have this, and let's say equal frequency. So let's say you know what? Rather, let's create a map from string. So let's say we have string statement equals to p ccs. So this is my statement. So what I'm trying to do right now, is going to count the frequency of each thing. So here, let's say we have, I made a typo and I wrote is once again. So what I'll do is for entire equals to 0, you know what? Same statement. You know what? Better yet, let's just make it a character. It's a little hard with the string. So I'll say statement of size. Because the frequency of statement of I. So now once we've created the map, let's try to access the values here. So we'll do is cout frequency of let's try to find the frequency of. Can I use a map? Okay. So let's try to find the frequency of y. Let's try to run it. Let's see if I get it. So yeah, y is present one time. Let me just zoom in for you guys. So let's say I change this entire thing to my name, and let's try to find the frequency of small a. I get 2 times. So this is how you use a map. But let's say there's no L present in my name because I don't take L. So let's try to find this. There is a 0. But that does not mean the map itself contains a mapping from L to 0. This is just the default value. So how do we iterate through this map? Again, we use for auto iterator is equals to map dot begin map's name to be precise. And we say that iterator is not equal to map dot end iterator plus plus. So done with that. This is a simple thing. Just say let's make it easy for you. I say that character current character is equals to iterator first and int frequency of current character. I'll use camel case for this. Also iterator. Once you're done with this, you simply do cout current character, and then you do frequency of this current character, and then you do backslash n. There is yeah again. This has to be the name of the map, not map. So once you do this, you see that I get. You see, this was an unordered map, so I get like random order. So it has I here and space here. By all means, this space should have been here. But let me just change this real quick. I'll change this. Yes. I should get this in order. You see, it changed. This zero is here. This space is here, then A, S, A. Even though I did check for L explicitly, it gave me a zero. But there is no L here. That was just the default value. This is how you create a map, and let's solve a question based on this. So I hope all of you did try some of the questions assigned. Let's try this. This also happens to be the lead code daily of today. Let me show you on the screen. I hope my screen is visible. So regardless, does anybody have any idea what this question is asking? Take your time to read it. I'll give you 2 minutes. Okay, time's up. Yes, Abhishek, please.
हाँ भैया, सो बेसिकली हमें मैप को यूज करके जो स्ट्रिंग है उसमें हमें सारे कैरेक्टर्स को हम की जो अक्रेंस है उनको हम निकाल लेंगे. देन मैप है तो ऑलरेडी वो सॉर्टेड ही होगा. हाँ, देन उसके बाद हम देखेंगे जो हाईएस्ट हमारी ऑड वैल्यू और हाईएस्ट हमारी इवन वैल्यू उनके बीच में डिफरेंस निकाल लेंगे हम.
Yes, exactly. ये करना है, but the thing is कि it's fine even if you use map या unordered map, वो कोई दिक्कत नहीं है. But main thing here is that you have to count the frequency. And you can use map to count the frequency or array to use the frequency. But here we are going to do, we are just going to use map. The thing is, यहाँ पे it's given that S consists only of lowercase English letters. Now, since you know this lowercase English letters is a continuous from small a to small z, so ideally you should be using an array for this. But since we did study map, so we are going to force ourselves to use this, solve this using map. So also order इसमें matter नहीं करता, so that's completely fine. So what we'll do is in n is equal to s dot size. Firstly, we do that. Next thing, we make a map. So n order map. So it's from character to int, and we're going to call frequency. Now for int I equals to 0, I equals to n. Plus simply just put the frequency. So frequency of S of I. Next thing we do is we have to iterate to the map. Now we have already got the frequency of each element. So simply iterate to the map. So for auto iterator is equals to frequency of begin. Iterator does not equals to frequency of end. Iterator plus plus. So you can also keep, let's say, int odd. A1 has an odd frequency in the string, A2 has even frequency in the string, difference frequency of your A max equals to let's say 1 A max. Rather, let's just set this to 2. So we say that if let's just take frequencies. Oh, sorry, I accidentally submitted this. Control enter दबा देता हूँ गलती से. So what we'll do is कि यहाँ पे we'll take temporary, or you can say frequency of this element. It's simple, we'll just take f. F is actually iterator. Now since frequency is actually of integer type, it is stored after the key. It's actually the value. So it's the second element. So we just write second. If f equals to 0, this is even. We say max even. That's the max of max even comma f. Otherwise, we will do the same thing. We say max or maximum difference is equal to frequency A minus. Okay, so the question actually asks us to say maximum difference. So that means you have to maximize this frequency and to find the minimum even frequency. So it's supposed to be min even. So we just simply do min even min, and max or is going to be max of. And I hope I did not mess up. So we'll just say max or minus 1. Let's just try to run this if this comes. Okay, there is something wrong here. It's just, okay, I'll just say, did you mean maximum? No, I didn't mean minimum. So, okay, good enough. So you see, what we actually did in this is very easy. We calculated the frequency using a map. So here we did highest odd value and lowest even value. Yes, exactly. Sorry. So this we did this thing, but ideally you should be using an array here because this is continuous. If there were different elements you did not know what the ordering the elements for, you could have used something like a map. But here you should have used an array, so that's fine. Let's go to the second question. This is a very interesting question. It's usually the first question of everybody. So I hope you would have done this. If you have not done, at least rate it. So what they're saying is you've been given an array, a vector to be precise. So you have to find two elements whose sum on adding gives us this target. And there are only two such elements present. So there's only one pair, one valid pair. I remember exactly one solution. Now, a very naive approach for this is what I would have a lot of solutions for this. Pretty sure. A very naive, yeah. A very naive approach for this is you start with every character and then you try to match it with every other character. So you could be doing 2, 7, okay, 9, 2, 11. In this case, we did find the answer very easily. But let's say something we start from 7, so 7, 11, 7, 15. And that is also fine. But the thing is, we can use an unordered map here. As I said before, unordered map is useful. So we can use this map so to easily find if we have encountered the required value. So it's very easy. Let's start in n is equal to size, and then we have for let's just create a map. So okay, I again submitted accidentally. Let's just say we have an unordered map. Now this is going to map my number. Since there is only one answer present, yeah, sure, please go ahead.
भैया इन द लास्ट क्वेश्चन वो मैक्सिमम डिफरेंस बिटवीन इवन एंड ऑड फ्रीक्वेंसी वाले में अगर हम
हाँ जी।
जो मिनिमम फ्रीक्वेंसी है ऑफ ऑड सॉरी इवन वाला राइट वो लेना है ना हमें तो फिर अगर हम उसमें जीरो लेंगे तो उससे तो नीचे जा ही नहीं सकता तो वो कभी मिनिमम फ्रीक्वेंसी रीच ही नहीं होगी वो जीरो ही मान लेगा हर इवन वाले को
तभी मैंने तभी मैंने लास्ट में इंट मैक्स कर दिया था उसने.
ओह सॉरी हाँ मैंने नोटिस नहीं किया सर
And then it's fine. It's actually a very valid doubt. But he's saying कि अगर हमने पहले जीरो ले लिया था minimum frequency. Now we know that minimumly किसी भी चीज़ की frequency if it's even it's going to be 2. But in this case we've taken it 0. तो वैसे तो कम होगा ही नहीं कभी. That's why whenever you have to find the minimum of something, you initialize it with int maximum find करना होता है. You initialize it with int min. The reason is int min से छोटा कुछ नहीं है और int max से छोटा नहीं है as long as you're using integers. So when you compare it with this, so it's like a infinite potential well. उससे छोटा कुछ नहीं है और int max में उससे बड़ा नहीं है. Whenever you find some minimum element, it's always going to be less than int max. And whenever you're going to find max element, it's always going to be greater than int min. So that's a very valid option. And in this case, what we are going to do is हम उस character उस number की पहले हम देखेंगे कौन से numbers हमने encounter किए and then we are going to say that कि वो किस index पे present है. So we are doing unordered map int. Now let me just write present or something like map. No, rather just let's say. So what we are doing is we are mapping the number required or the numbers encountered to its index. The reason we're doing this is because there is only one valid pair. So if there was, let's say, two or three valid pairs, so we could have returned any answer. In that case, also it would have worked. But इस case में वो unique है, so it's very easy for us. That's why we're mapping the numbers in the keys, क्योंकि keys unique होनी चाहिए हमेशा. So let's just go there. So what we'll do is, so for int I is equal to 0, I is less than n, I plus plus. I'll tell you one more important thing here: how to see if a number is present or not in a map. So what we'll do is first we can say int current number is equals to nums of I. Now, if you have nums of I and you have a target and you need to make the target, you require target minus that current number. So int require equals to target minus nums of I. I'm just going to run instance. Okay. This can also be negative, so I can use long runs. It's fine. So int is target minus. Now we have to check if this target we have already encountered. So so how you do that is you take map and then you say if m dot find required is not equals to m dot end. So what this says is if you try to find something from this map and that does not point to the end, if something does not point to the end, that means it is present inside. If something points to the ends, it means कि वो present नहीं है उसमें. So this statement says कि अगर whatever I'm trying to find this required, if that does not point to the end, that means it exists in the map. So I can simply say return and create a vector on hand, and I'll just say return. You have to return in this order 0 1 1 2 0 1. So firstly you have to return the small index. So in this case the small index is of course going to be where this is present. So I'll just say int smaller index equals to m of required. So I'll say smaller index y, and it does say na कि there is always an answer, exactly one solution. You may not use the same element twice, of course. So if that is not the case, if it is, you can also omit else here, because if this thing runs, it's just going to stop. But it's fine if you want to use else. I'm just going to add it to it. I'll just say that m of current is equals to, if I use nums of I, I can use current. So we do not will always return. Let's just say return a trivial vector here. So let's say if it runs. Say it runs. So my main point here teaching was how do you use this. So अगर तुम्हें map में कुछ देखना है if that value exists or not, what you do is you say map dot find and then this value whatever you're trying to find. Remember this is actually the key. When I say value, I mean that this is the key, and this required. Is this required mapped to something in this? So if it is mapped, it will return. It will say that okay, it is somewhere. It will return its iterator, and if that iterator is not equals to the end, that means it is present. But if it returns an end, that means it is not present. I hope you समझ आया हो. किसी को अगर नहीं समझ आया, please raise your hand so just let me know.
ये तो हम बेसिकली इसमें लाइक अगर हमारा जो डिफरेंस जो मतलब टारगेट में से हमने जो करंट को माइनस करा तो हमारा जो रिक्वायर्ड आया, हाँ, तो अगर वो प्रेजेंट नहीं हुआ तो हमने उसे मैप में ऐड ही कर दिया एज अ की वैल्यू पेयर.
हमने टारगेट को ऐड नहीं किया. हमने जो ऐड किया है इट्स एक्चुअली कि हमारा जो करंट एलिमेंट है, क्योंकि हो सकता है जो करंट एलिमेंट है वो किसी आगे के लिए टारगेट हो.
ओके, एंड इसीलिए हमने फिर अज्यूम ही कर लिया जो हमें इंडेक्स अपने मैप से मिलेगा और अनऑर्डर्ड मैप से मिलेगा दैट वुड बी कि वो उससे स्मॉलर इंडेक्स ही होगा.
हाँ, yes, let me just share my screen में दिखाता हूँ how is that possible. So I'm going to do in my drawings here. So very valid doubt. The thing is, let's say we have three 2, 4, 7, and we need to find key if it is possible to create a 7 with this or not. Of course, you have to use two values. ऐसे नहीं कि तुम सिर्फ 7 के साथ कर दो. So this is initially our, let's say it's a let me just do this. Let's say this is our maps the value. In this case, let's say the value of num5 to its index, or simply key value pair, key value, and this is going to be nums of I, and this is going to be index. तुम करके रहे, we first go ahead. You see that this is a 3, and you need to make a 7. So you need a 4 for this, right? Since you need a 4, you check क्या वो मैंने 4 अभी तक encounter किया है. You haven't encountered the 4, so okay, do not worry. You just put that there is a 3 present at 0 index. Then you go forward, and there is this 2, and then you say, okay, for this 2, if I have to make 7, I need a 5. You say, okay, I need a 5. Is that 5 present here? So in this case, what is going to happen is that your map is going to try to find कि उसमें 5 है नहीं. So it is going to return end. Very poor handwriting, you know. It is going to return end. So that end iterator, it tells you that okay, वो map में present ही नहीं है. So since it's not present in the map, you just simply add this 2. तुम बोलते हो that this 2 is present at this one index. You go further, you say 4. So this 4 to make 7, you need a 3. You need a 3, right? So since you need a 3, you check your map में present है. And since you search using the find thing, it will not return end. If it does not return end, that means कि 3 present है, and that 3 is present at index 0. Now since we have one required and one current, so 4 is our current, 3 is our required. So अगर required already present है, that means वो required पहले आ चुका है. So that's why we return 0 first, that is this required index, and then we return the current index. So it's like 0, 1, 2, 3. So we first return this 0, and then this 2. So this is our answer. अगर तुम उल्टा करते, that would be like 2, 0. That would mean कि तुम्हारा current का क्या index है, and then the required index. So did you understand, Abhishek?
जी भैया, थैंक यू.
Okay. कोई और डाउट?
भैया जो हमारा यही क्वेश्चन है उसके कोड में आप ये बता सकते हो काइंडली कि हमने कहाँ पे मेंशन किया है कि द वैल्यूज आर इंडेक्स.
एक सेकंड, दोबारा डाउट प्लीज. सॉरी
सर इसका भैया इसका कोड शो करना.
हाँ, एक सेकंड.
इसमें काइंडली ये बता सकते हो कि हमारा जो कीज पॉइंट कर रही हैं वैल्यूज को, तो हमें ये कौन सी लाइन से पता लगेगा दैट द वैल्यूज आर इंडेक्सेस.
हाँ, so ऐसे तुम्हें पता नहीं लगेगा. यू हैव टू फिगर दैट आउट. द रीजन वी डू दैट इज कि आई शो यू. तो फर्स्टली वी गो हियर, राइट. इट्स वेरी इंपॉर्टेंट फॉर इंट्यूशन बिल्डिंग कि गिवन एन एरे ऑफ इंटीजर्स, नम्स एंड एन इंटीजर, तुम्हें क्वेश्चन समझना है. सो द क्वेश्चन सेज कि तुम्हें इंडेक्स रिटर्न करना है. सो वंस यू नो तुम्हें इंडेक्स रिटर्न करना है, नेक्स्ट थिंग यू लुक एट इज एग्जैक्टली वन सोल्यूशन. नाउ दिस इज वेरी इंपॉर्टेंट. अगर उन्होंने तुम्हें कहा कि एग्जैक्टली वन सोल्यूशन है, दैट मीन्स हर नंबर इसमें जो है, थिंक अबाउट इट, हर नंबर इसमें यूनिक होगा.
हाँ जी भैया.
When you're trying to return an answer, that is when. But is this case में अच्छा एक second, अच्छा never mind. So what I'm trying to say is that when it says exactly one solution, तो उसका मतलब है कि if you're trying to form the answer, तो जो आंसर में जो दो numbers हैं, for example if you have 7, right, तो अगर तुम 7, if you're trying to form 7 using 3 and 4, तो 3 के साथ हमेशा एक यूनिक नंबर 4 ही आएगा. 3 के साथ तुम 3 नहीं लेके आ सकते, 3 के साथ तुम 2 नहीं लेके आ सकते, 3 के साथ तुम 1 नहीं लेके आ सकते. That's right? Because if you add two numbers, it has to go to a single number. You can't have two answers from addition of two numbers, right?
हाँ जी भैया.
So once you're done with that, that means कि जब भी तुम्हारा कोई current number है और तुम्हें कुछ required है उसके साथ, so that requirement is going to be unique. You see, तुम्हें 7 बनाना था, you had 4, so that means you need 3, right? So that means वो 3 पीछे सिर्फ एक ही इंडेक्स पे प्रेजेंट होगा. अगर वो एग्जैक्टली वन सोल्यूशन नहीं होता, दैट वुड मीन वो 3 एक से ज्यादा इंडेक्स पे प्रेजेंट है, एंड देन दे कुड हैव सेड कि चलो रिटर्न द लोएस्ट इंडेक्स और रिटर्न द हाईएस्ट इंडेक्स और रिटर्न द मिडिल इंडेक्स जिसमें को आंसर मिल रहा है तुम्हें. यू गेट इट व्हाट आई एम ट्राइंग टू से?
हाँ जी भैया.
सो दैट इज व्हाई उन्होंने कहा कि also you can return the answer in any order. I did not look into that, but that's fine. हमने कंस्ट्रेंट लगा दी कि हमें पहले स्मॉलर इंडेक्स डालना है. That's completely fine. 0 1 1 2 0 1, that's fine. So the thing is कि this is very important. That's why they've highlighted that exactly one solution. This is how you know कि map में तुम्हें key कैसे रखनी है, because keys are always unique. So you know अगर मेरे पे कुछ current element है, मेरे को उसके corresponding कुछ element चाहिए last के लिए आंसर बनाने के लिए, तो वो यूनिक होगा. So that's why you put it in key. Also you also know कि तुम keys के साथ values access कर सकते हो, but तुम values के through keys नहीं access कर सकते. So that's why when you have to find the index of something, तुम उसके लिए वो यूज करते हो, बस तुम वैल्यू डालते हो उसके बाद इंडेक्स डालते हो. Had you done it differently, had you done it index to value, वो कोई फायदा भी नहीं होता, because you can do the same thing in an array, right? You can put the index and get the value, but you can't put the value and get the index.
Okay, thank you, भैया.
Any other doubt? Sure. So dot find, right? So let's talk about this dot find. Remember I said that maps can go, it's either constant or ofn. That dot find actually really depends कि तुम्हारा optimized कितना optimized वो hash function. In this case it's of 1. So वो dot find actually does it, वो constant time में निकाल देता है कि तुम्हारे उसमें present है नहीं है. But let's say तुम्हारा hash function is very poorly built और तुमने ज़्यादा operations भी नहीं लगा रखे, it's very bad in some language, let's say. So it will take an of n. उसे वो हर वैल्यू के साथ मैच करना पड़ता है. क्या ये हैश फंक्शन के साथ जो वैल्यू आ रही है इसमें कोई और कोलिजन्स तो नहीं है. So dot find is basically, you can say, runs in of 1 average, or in worst case it can go of n. That is why we say unordered map is actually very fast compared to map, because map uses of log n. Can you give an example of the lattice? Yeah, sure. Let me change my screen. ये पढ़ लो भाई, तुम्हारे बाद में आएगा. हैशिंग इज वेरी इंपॉर्टेंट. सो एज यूजुअल आई एम गोइंग टू गो इन दिस स्क्रीन. सो द थिंग इज, लेट्स से तुम्हारा हैश फंक्शन है, इट्स वेरी बेसिक हैश फंक्शन. लेट्स से हैश फंक्शन इज mod h mod, you do understand what a modulo function is, right? H mod k, where k is, let's say, 10, right? So let's say you have you're trying to make a hash map, और तुम्हारे पे वैल्यूज है 2 5 12 22 32. Most of you would know where this is going. So तुमने एक हैश मैप बनाया, right? You have this key and this value. So since you have this 2, what is 2 mod 10? 2 mod 10 is 2, right? So what's going to happen is कि तुम्हारा जो key 2 है उस पे it's going to store this 2, right? It's going to allot this index of 2 to this 2. But once you go to 5, it's going to allot 5 more 10 is 5. So it's going to allot an index of 5 to this 5. Alright, forget about this as of now. I'm just saying about indices. So जब तुम 12 पे आते हो, again 12 modulo 10 is again 2, right? So what's going to happen is, let's say तुम्हारा hash map optimized नहीं है, it uses a list after that. So यहाँ पे 2 था, but then after it goes कि यहाँ पे 12 आ गया. It's in a continuation, right? पहले 2 है, उसके बाद 12 है, एक पूरी list है. And then this 22 32. So what's happening is यहाँ पे 22 है, then let's say यहाँ पे 32 है. You see what happened here is कि you had 5 values, and to check if 12 or let's say 32 exists, so what's going to happen is it's going to do 32 mod 10. ये 2 पे जाएगा, it will see okay 2 पे मेरे पे 4 values है. Now it has to go through this entire 4 values to see if 32 is mapped with something. Let's say 32 is mapped with A, Arman's name, right? You know, just write your search. So let's say 32 is mapped with my name. So it has to go through this entire list to see if 32 is mapped with something. You see, if you use a very poor hash function, in this case you use h mod k, जहाँ पे k 10 है, so ये list में store हो रहा है. So 2 has 2, 12, 22, 32. Now this 2 is the index, it's not key. Remember, key is your 32. तुम check कर रहे हो क्या ये 32 key पे कुछ associated है. मेरा नाम डाला था, so 32 is getting an index of 2. तो यहाँ पे 2, 12, 22, all these are also getting an index. Let's say, how do you optimize this? How do you make this better? Let's say use something like h mod k plus n, where your k is, let's say k is in prime number like 7. So what's going to happen is 2 mod 7 is going to give you 2, 5 mod 7 is going to give you 5, and 12 mod 7 is going to give you I guess 5 again, and 22 mod 7 is going to give you 1, and 32 mod 7 is going to give you 28 4. So in this case you see हमारी collision एक कम हो गई, दो कम हो गई. You had 4 collisions here, now you have just 2 collisions, 5 or 5. So using a better hash function actually results in a better map. For C++, they use very different techniques. Like there is a technique known as double probing, single probing, and there are also bigger numbers. For example, 10, this one 9 plus 7. I guess it's 9. This is a prime number, so it's a very good hash used for hashing. Shaurya, did I clear your doubt? Yeah, maybe doubt it's completely fine. You can let me know. Yes, okay. So anybody else has a doubt?
भैया सो मुझे बस ये हैशिंग का एक चीज पूछना था कि हम खुद डिफाइन करते हैं कि कौन सा हैश फंक्शन हम यूज
नहीं
करेंगे.
नहीं, तुम कर सकते हो, दैट्स अप टू यू. ऑफ कोर्स तुम मैप्स में नहीं कर सकते, तुम अनऑर्डर्ड मैप में कर सकते हो. तो दैट्स अप टू यू, बिकॉज समटाइम्स देयर आर क्वेश्चंस ओनली टू द फर्स्ट प्रेजेंट जिसमें यू हैव टू बी वेरी कनिंग टू यूज हैश फंक्शन. तुम्हें कुछ अपना बनाना पड़ेगा सो यू कैन इजीली सॉल्व, बट दोस आर वेरी फार फेच्ड, कोई दिक्कत नहीं है. C++ हैज इट्स ओन अनऑर्डर्ड मैप में हैश फंक्शन बहुत अच्छा, एंड इट यूजेस दैट. So you see, hashing is very helpful. You just take whatever you have, and let's say you had two, so you perform some operation on this. This gives you an index. So let's say it gives you an index of 3, and then उस 3 पे मैं कुछ भी मैप कर सकता हूँ, which will be actually mapped from 2 to that number. Let's say 2 पे मेरा नाम था. Let's say 2 is corresponding to A. But जब मैं 2 दोबारा fetch करने की कोशिश करता हूँ, what the map does is it takes 2, it performs the same operation, and since you perform the same operation, it's going to get an index of 3. तो उसने अपने कहीं database में it has stored 3 पे A. So this is what's happening. You do this, you get some index using a hash function. At that index you have a value. अगर let's say उस index पे कुछ है ही नहीं, so that would return end. It would say कि यहाँ पे तो कुछ है नहीं, so you have not mapped anything to this truth. Now I think time भी काफी हो चुका है. Sets are similar. So I'll say तुम्हारा homework है थोड़ा सा set पढ़ के आना. I'll teach it again tomorrow. Sets is similar. Sets में तुम कुछ mapping नहीं करते. What you do is simply set में तुम numbers डालते हो. As you know, in a set, numbers are always unique. So if I were to add 2, 2, 3, 1, again the result would just be 2, 3, and 1. Similarly, there is also unordered set. तुम्हें आइडिया लग गया होगा unordered set क्या है. उसमें random ordering होती है. You do not know in which order we are stored. And set में ordering होती है. So it's very easy. Let's say I have an example. A question है तुम्हारे पास that there are let's say there are 100 students in a class, and then you have been given the birthdays of all those students. अब तुम्हें ये बताना है how many unique days are present जिसमें किसी न किसी का तो बर्थडे आता है. So what you do simply you put the entire birthday thing, the dates in the set. So what it's going to do is let's say एक दिन में 5 लोगों का बर्थडे आता है, so it's just going to take that one singular entry. तो उस हिसाब से you can use set easily. Now unordered set again uses hashing, and set does not use hashing. It uses sorting in that. तो उसमें already sorted order में होता है. These two things are also very important and very useful. When you do stuff like graphs and all, तो उसमें अगर तुम्हें unique कुछ ढूंढना होता है, you can easily use sets. It's very easy. And again, the same time complexities apply here. This uses O of 1 average and O of n worst case. This uses O of log n all the time. You know how log of n? Because it is sorted, so it's very easy to find the number if you know what binary search is. Now homework is learn about sets, do something about sets. I'll of course teach it again, and also there's one is homework. So we talked about default behavior once you have the key with the value as integer. So try if boolean के साथ भी same behavior आता है, same default value false आती है नहीं, and let me know. And from I think a day or two from we'll like start practicing proper questions. हम सिर्फ questions करेंगे, theory नहीं करेंगे. Theory जहाँ पे तुम्हें चाहिए, I will teach you theory, and that would be a lot more fun than today. I know तुम लोग bored हो चुके हो. So if you have any doubt, just let me know. any doubt regarding today's session or any doubt regarding any question, any like daily question या वैसे तुम्हारे पास कोई question है you want to discuss, just let me know. तुम्हारे mics on हो सकते हैं, I have allowed you to do that. Okay, I'll take this as किसी को कोई doubt नहीं है. I'll take this as a compliment. You know, more like an insult rather, but never mind. So thank you so much. And yes, code board. So there is a platform by CCS. Most of you guys might know about codeboard.ccscid.com. Let me just change my screen.
भैया आपका माइक बंद है.
Oh, yeah, sorry. Thank you. So this is codeboard by the way, and you have to log in your using your Thapar mail here. Like CCS auth के साथ तुम्हें log in करना है. And this is a very handy tool. Like you can see कि daily में तुमने कितने questions किए हैं, and of course we have many people, very known people here. Weekly leaderboards, monthly leaderboards. We will also be hosting many competitions over here. So I will give you questions. We will be having contests very soon. Once you've done enough questions and once we've given you enough lectures. So here is the monthly rankings. Then there's daily, there's weekly. Also it refreshes after every month, after every week. And then you have your profile. You will see questions here. आज कोई questions नहीं है. So once we start uploading the questions here, you'll see your questions that you have to do. तो जो कोडिंग कम्युनिटी में क्वेश्चंस डिस्कस होंगे वो यहाँ पे आ जाएंगे डायरेक्टली, एंड देन you'll see its difficulty, if you have solved it or not, and then you can also track कि कितने लोगों ने आज किया, कितने लोगों ने आज नहीं किया. So that's it. And trust me, it's a very great platform. Once you get into the habit of being accountable with someone, you can easily see उन्होंने कितने questions किए हैं, खुद ने कितने questions किए हैं. And we will be starting tomorrow यहाँ पे questions upload करने. And remember to always check on how many questions you have done or not. So keeping track is very healthy. Also do not think कि अगर तुम्हारे daily question आज का है and you do it tomorrow, it's going to show it. That's not going to happen. So आज के questions आज ही करने हैं, and that is intentional behavior. Apart from that, the URL is codeboard.ccscid.com. We will also put this in coding community. And I think that's pretty much it. Any doubts? So I think that's it. So let's wrap.